previous recording, you don't really show up. All what shows up is your circles with a letter in it. Okay, right. So this is the second lesson now for calculations in chemistry that you're going to need for level 2 chemistry as well as for level 3 chemistry. And what you should be seeing, I hope, is the landing page for level 2. Can somebody just confirm that in the chat by saying yes or no? Can you see the landing page? Right, sorry, I just need to, yep, great. Okay, so you can get this document that I'm working with by going to content. So I've just click on content, and then you've got over here the list of things, and make sure you just scroll down until you get to the CH 2.1 carry out quantitative analysis. That was an old standard, so don't work through the module, only go to the very first lesson, the landing page for that module. And when you do all that, then you will see some documents and an answer guide. So there is the docx version if you want to type in directly, or PDF if you prefer printing and handwriting. And then, of course, it's important you have the answer guide so that you check your answers as you go through to make sure that you are on the right track. So that's what we're going to be working through mainly. And then as we do more examples, I'll be showing you other things too. So I will show you what it looks like. Let me just check. Yep. So this is what we looked at. And yesterday, or last week, we looked at counting atoms and counting the enormous number of atoms. And you'll also see as you work through the booklet, you can also complete certain questions in the teacher marked assignment. But as was pointed out last time, you don't have to do this work if you're currently working through, say, 2001 or another standard. You can do this at any time. Just as you join the lessons, at least when you come and do the booklet, it'll be a lot easier. So let's look at the calculating a molar mass, because that was where we were more or less last time. Now, molar mass, you need the mass of the atom, and you are always given the periodic table, and you please use that periodic table because that will give you the molar mass down here. So this might be a little bit small, so I've made it bigger over here. Oops, I'm going to be going back to that joke a little bit later. So hopefully you can see that. And you'll notice all the molar masses are given to 1 decimal place, and that's important. So please make sure you use the molar mass including the 0. If you're only aiming for achieved or merit, it's not important, but it is good practice because that tells you how accurately we have measured the mass of an average carbon atom. Now, I say that of an average carbon atom because the mass of an atom is only dependent on the protons and the neutrons. And of course, you can't get half a proton or 1/5 of a proton or something like that. So what they do is if you have atoms that have isotopes, in other words, differing number of neutrons, then those ratios of the different type of isotopes tend to stay the same, unless there's a nuclear reaction or Chernobyl or something like that, seeing that's been in the news recently, then you can change the ratio of isotopes. But so what is given in the periodic table is the average mass. So for instance, there's only 1 isotope of fluorine, so it's 19.0. There are 2 isotopes of oxygen, but 99.9% of it appears as oxygen 16. So it has a molar mass of 16.0. Very, very little of it is the other isotope of 18. Lithium, you'll notice, is 6.9 because most of the atoms for lithium have 4 neutrons. So it's got a total mass for those of 3 protons and 4 neutrons of 7, but some have got only 3, and that's why it's lower. So what I'm trying to point out is please use your periodic table to get these average molar masses for the individual elements. You will be thankful to know that in any assessment task at level 2, so if you're doing the 91910 titration standard or you're doing the 2 exam standards, the molar mass will always be given. Why I'm teaching you this is because you do need to know how to calculate it for level 3. So in your teacher marked assignments, 2011A and 2012A, you are going to have to calculate molar masses. So how do we calculate molar masses? What you have to do is, if I just go back to the booklet again, you need to work out how many atoms of each element are in that formula that you're given on that compound, and then you just need to add them all up. So it's as simple as that. And so as an example that I've got here is I had sodium sulfate. Now, sodium sulfate has got 2 sodium atoms, 1 sulfur atom, and 4 oxygen atoms in 1 formula unit of sodium sulfate. So I need to look at the periodic table, and I'll find that the molar mass is 23.0. The molar mass for sulfur is 32.1. Now notice I'm ignoring the units at the moment. I will get back to those. And the molar mass for oxygen is 16.0. So if I flip back here again, you can see 16.0, 32.1, and 23.0. So you would look that up. And now you would just simply say, okay, I've got 2 sodium atoms, so I need to multiply the molar mass of sodium by 2. I've got 4 oxygen atoms, so I must multiply it by 4. And then I've got only 1 sulfur atom, so I multiply that just by 1, or just leave it like that. And therefore, you just be very careful you don't make mistakes. I find a lot of students make calculation errors. They know that they have to double this. They know they have to multiply that by 4. But somehow when they take shortcuts and just dump it all in their calculator, things come out wrong. So make sure you are very methodical and you perhaps do extra lines. So don't just go from there to there, because you could just make a mistake. Rather put in like that extra bit or even that bit, just to make sure you are on the right track. So that's a simple of working out molar masses. Where it gets a little bit tricky is if, say, you've got the brackets in there. So sorry for letting it move down like that. I know my eyes always go weird. When you've got brackets, that's why last time we spent some time on adding up how many atoms of each element are there. So remember, you have got 6 oxygen atoms. Now, for those of you that can't, because this is a bit small, let me just pump it up a bit bigger. Can you see it's PB and then bracket NO3 bracket 2? That means I've got 2 nitrates, which means I've got 2 nitrogen atoms, and 3 times 2, which is 6 oxygen atoms. So I need to multiply my molar mass of oxygen by 6, and then 2 nitrogens and 1 lead. And lead, you can see, is very, very heavy. So it's double the amount of 6 oxygen atoms, pretty much more than double. Any questions about that? Anybody not quite sure why I've doubled some, or multiplied by 6 or multiplied by 4? All good? Okay, right. So what I want to go to now is, of course, where do we get these units from? It's really important that you start learning units and linking them to the symbol and then to the quantity. So you'll notice I've got a symbol here. That N is the symbol for nitrogen, and that O is the symbol for oxygen, and PB is the symbol for lead. But this capital M, which is often written in italics, is molar mass. So one way I remember, it's a big M. It starts with M, molar mass, and it's like a double M, molar. So there's an M in the first molar and a M in the mass. So it's big because it's got a like double M. So it's a capital M. So that is the symbol for the quantity, molar mass, the mass of 1 mole of a substance. Now remember last time we finished off with, when we were counting atoms, they are just so tiny we can't see them. And so the way we have worked out how to count atoms is using their mass, where if I take the molar mass of anything, then and I weigh out exactly that amount. Hi, Maddie, you might want to switch off your camera. It just will reduce the bandwidth. Thank you. So if you weigh out exactly 16.0 grams of oxygen atoms or oxygen gas, it means there will be 1 mole of oxygen atoms in that mass that you've weighed out. So that's the way they've worked out this quantity called mole. And remember, mole is a very big number. So if I just quickly go page up, remember I ended off yesterday or last week where I said if I took 1 mole of dollars and divided it amongst every person in the world, man, woman, and child, you'd all be multi-trillionaires, because a mole of dollars is an enormous amount. You've got to draw 23 zeros after the 6, and that will tell you how many, how big it is. And that weird number was just chosen because it just makes counting atoms so much more simple. Right. So what I'm trying to point out is you must learn the units, which is gram per mole, or we can make it shorthand of G over M OL, or the standard form is to the negative. So I'm going to just quickly draw on here. I'll get back to that just now. These are the quantities you're going to need to know, and their units and their symbols. So the first is mole. Now mole is an amount. So we measure amount in mole. The symbol for amount is N. The symbol, well, it's actually the whole unit is mole, furry brown creature. But the way we abbreviate it is just MOLE. If we have another quantity like molar mass, then the symbol for molar mass is capital M. As I said, it's often written italics, and the unit is gram per mole. And we can write it as gram. You can write it as gram per mole like that, or you could write it as gram a mole minus 1. I'm just going to move my cursor away from here so we don't have that flashing. Then the last quantity you need to know that we're going to be dealing with this lesson is mass. So these are the quantities. If I say calculate the amount, it means you need to use the symbol N and you measure it in mole. If I say calculate the molar mass, you need to solve for capital M, and the unit will be gram per mole. If I ask you to calculate the mass, then the symbol for mass is small m. And we measure mass in not kilograms, which is a sort of standard form. If you're doing physics, we'd measure it in gram. And the abbreviation for gram is G. So make sure you spend time learning that. I've got in the booklet, if I just flip over here and I just go down. Sorry, I'm just going to flip down very quickly. We're going to get back to that practice soon. I just want to over here. This is what I wanted. So remember I said that amount, think of the N, an amount to make you think, or a number of particles, like it's a number, it's an amount. So it's a symbol of N. Mass, it's a small m. Molar mass, because you've got an M and an M, it's a capital M. And then the unit mole, gram, gram per mole. And a way you can imagine these things is, I've got it like this. We're going to get to this formula soon, where the molar mass in our general formula as it's given is a great big muscle man. So, you know, MM, big one, so he's at the bottom, and the titchy little man is at the top. So M for little man. And you wouldn't expect it the other way around. You wouldn't expect the titchy little man at the bottom and the big man at the top. So that might help you remember the formula. And then also that molar mass has a symbol of a capital M and mass small m. It's a lot of N's, M's, big M's, and so on. So just spend some time getting your head around that. Okay, so in the sort of 10 minutes or so remaining, what I want to just do is very briefly an example of calculating a molar mass, and then also introducing the issue of errors. So I'm just going to flip back to the practice over here. Now you'll be doing this sort of thing, but if you're asked to calculate a molar mass, and I always say with these booklets, you don't have to do necessarily every single example. Make sure you do the first a few and the last few. So here you would write, let me just say blue, the molar mass. Practice doing the symbol of it. Don't just say 18, okay? Try and show full working. It'll really embed the concepts. So later on, as you do more difficult examples, you have different substances. So it's always a good idea to say what molar mass you're talking about. I'm talking about water. Now, it's pretty obvious here because I've just asked you to calculate water and I haven't given you another substance. But get into the habit of linking the quantity with the substance. So here now you would look up in the periodic table. So you would go over here and you would go right. Hydrogen is 1.0. Oxygen is 16.0. And so we would say it's 2 times 1.0 plus 1 times 16.0. Oh, I don't have to really put that last thing in there. And therefore, it's going to be 18.0. Now, if you just leave it 18.0, you're not going to get excellence. You have to have the correct number of significant figures, and I will explain that just now, and the unit for all your calculations. So remember, the unit is gram per mole. And by practicing it and putting that in for every one of these examples, you'll more quickly learn that unit. Any questions so far? Nope. Okay, so last thing I want to do is I've been stressing that you need to put in this 0. You know, why? What's important about it? The important thing is it's a measurement. And how accurate or how reliable your measurements are is really important to say whether your answer is actually valid or not. So what I've got over here is this cartoon where basically this little person is coming in and saying, how old was that dinosaur? And the chap says, oh, 3,002,000 years old. And so this little chap's really impressed and says, oh, how do you know so exactly? And then the security guard says, oh, when I started working here 2 years ago, I was told it was 3 million years old. Now, can you go from 3 million and 2 and then come up with an answer of 3 million and 2? What do you think? Is that a valid sum where years are being our measurement? Could we say, yeah, correct. Could we say that dinosaur is 3,002,000 years old? Now, please, I don't want to start a debate whether dinosaurs are 3 million years old. Okay, I just picked a figure. I didn't want to make it an a difficult number. So I've just made it like 3 million to be a big number. So what we've got here is what we talk about in terms of significant figures. We're saying that number has a value, but all the zeros after that could be approximations. So is it 3 million or is it 3.5 million or what is it? It's approximately 3 million years old. So the only figure that we can put some value on is that first number 3, and we can't consider the rest. So we say that we have here one significant figure, okay? Because we can discount the others. They're not significant. For the 2, we've only got one number, so we count that as being significant. So we say there's one significant figure over here. But when we go to this bottom number, we've got to, by the significant number rules, and I will be going over those, we've got all those numbers. So I'm going from approximate measurements with only one significant figure to I'm saying it's 1, 2, 3, 4, 5, 6, 7. There are 7 significant figures here, which means I've got a very precise measurement. And you can see that that is obviously not the case. I can't say so precisely that that dinosaur is 3,007,000 years old. So this idea of significant figures is a way of giving us a measure of how accurate or how precise our measurements are. So it doesn't count for factors. If I had two sodium atoms. So if I go back here, or 4. So this is a measurement. That is a measurement, but this is not a measurement. This is just saying I have got 4 atoms. So I'm multiplying by 4. It's a factor. Okay, the same thing over here. This is a factor. So we don't talk about, 4 has only got one significant figure. We only talk about significant figures in terms of measurements. So what I want to go through the rules very quickly is, now I might actually have got, sorry about this. No, okay. The significant figure rules come below. I'll get back to that errors a little bit later. So these are the rules. Any number, so 1, 2, 3, 4, 5, 6, 7, 8, 9, okay? Any what we call non-zero numbers will always be significant. If the tricky bit comes when I've got 0 numbers, because it depends where the 0 is. As in our case of that 3,002 years, if the 0 is between two non-zero numbers, we count it as a significant figure. You know, it is part of the accurate measurement. If it comes after a number and no decimal point is present, then they are not significant and we can ignore it. So let me actually just say, I'll put in this color. These are not significant. Okay. And any zeros before a non-zero number are also not counted. Oh, sorry, I meant to change that color. Sorry. So those are not counted and those are not counted. So this can make things a little bit tricky, and that's why scientific notation was brought in to make sure it was very easy to see whether numbers were significant. Because did I mean 100 exactly? Okay. Or did I mean it was approximately 100? And that's why we have this, what we call scientific notation. There's a difference between saying 100 or saying 1.00 times 10 to the 2. Because when I put in a decimal place, then that immediately makes all those numbers after the decimal place, sorry, it takes ages to change. So it makes all those numbers significant. Whereas over here, for the 100, the zeros are not significant. So going over here, I have a decimal place, which immediately makes all those numbers significant. So I have 4 significant numbers, whereas here there's no decimal place, so I only have 1 significant figure. Now, you just need to practice with this to make sure you get used to these things. Remember, if this sounds all a bit much, significant figures are only important for excellence, but you must get them right for excellence. So there are also examples that you can work through, and let's do a few over here. And so very quickly in the last minute, how many significant figures are there in 1.1? You can type in the chat. 2, correct. That's significant and that's significant. What about 250? 2, because that's significant, that's not significant. What about 300? 1, correct, because that's significant, but because there's no decimal point, those are not significant. How about this one, which is 0.0860? 3, correct. That's significant, that's significant, that's significant. These are not significant. Numbers before a non-zero number are not significant. What about this one over here? Now, some of you may actually have answered that. I must choose one where it's not the same answer. Yep, so that's 3 because that's significant, and because there's a decimal point in there, I don't know if you can all see it, but that immediately makes the numbers, the zeros after that, significant. Okay, so we've done a half hour, so we stopped there. So pretty much what we've done so far is we can count atoms. We know about now quantities and their symbols and their units. And we know about how to calculate molar masses by always referring to a periodic table and including those zeros. And we have looked now at significant figures. So next week, what we're going to be doing is we're going to be doing the calculations with those quantities. I'll go back and do the error bit that is earlier on. I will do that a little bit later in our session. Any questions? Nope. Okay, so I'm going to stop recording and see you next week. And if you want me to go over something or give you more detail, let me know.